Hi, I'm Kian, and today I want to show you how to find if a series converges or diverges using the limit comparison test. So we have this series from 1 to infinity of sine of 1 over n squared. And now for first of all, before solving it, for limit comparison test, we should know what is our main series and what is the series we want to choose as a known value. So in this case, the whole sine of 1 over n squared is our a sub n. And then for our known series, which we know it converges or diverges. In this case, I want to choose 1 over n squared. So I take the series from n equals 1 to infinity of 1 over n squared. And also we can write it because p is equal to 2, the power is equal to 2, which is greater than 1. This whole thing converges. Now for limit comparison test, what we should do is that we should take the limits as n approaches infinity of a sub n over b sub n. A sub n is the original series, and b sub n is the 1 over n squared that I chose as my known value. So if I do that, I get the limit as n approaches infinity of sine of 1 over n squared all over 1 over n squared. But we have a problem. If we plug in infinity, we get sine of 1 over infinity, which is the same as sine of 0. We get 0. And then 1 over infinity is 0. So we are in a 0 over 0 situation. So we can use L'Hopital's rule, but we don't, because we have an easier method. We can set theta, can have a substitution, to be equal to 1 over n squared. And also, if we evaluate theta at infinity, 1 over infinity is 0. So our new limit should approach to 0. So we get the limit as n approaches 0 of the, and then we use the substitution sine of theta all over theta. And to all students, this should be a very familiar limit. Using L'Hopital's rule or definition of limit, we can prove this. And this approaches 1. So the whole limit approaches 1. And what we're hoping to show is that 1 is greater than 0, because in the limit comparison test, we should have a positive finite number. And because of that, we can make a conclusion that the series from n equals 1 to infinity of sine of 1 over n squared also converges by the limit comparison test. Thanks for watching. Please subscribe to my channel and watch previous videos.